Good morning, class. We are looking at pre-calculus practice test number 4, module 4, covering chapter 8, application of trigonometry, polar coordinates, and vectors. So here's the first part, application of trigonometry. We want to find CD, so let's see how we are going to tackle that. Notice this is a straight angle of 180 degrees. Therefore, the angle ABD, this angle, is 180 minus 36. This is 180. So this angle is 180 minus 36, which means now this angle BDA must be 18. Why is that? Because the total interior angle of any triangular shape is 180 degrees. So we are going to subtract the sum of 144 and 18 from 180, and this becomes 18 degrees. Now, AB is given as 200, so is BD, because these two angles are identical, and we are dealing with an isosceles triangle. Now let's look at this small right triangle. Sine of 36 degrees can be evaluated as CD over BD, the opposite over the hypotenuse. So CD is missing, and we found BD to be the same as AB 200, and practically we are done. The cross product will give us the answer. As far as the number of decimals, always use enough number of decimals and then make a decision according to what they ask you. We want to solve the right triangle where A is given as 8, B is given as 2, capital C is equal to 90 degrees. We plug in lowercase. Letters represent the size of sides, and uppercase represents the angle. So this is 90 degrees. And this is lowercase c, by the way, therefore. This is A, lowercase a, opposite A. This is capital B, opposite that, lowercase b, and we plug in the values. Even if the numbers are not necessarily to scale, it's fine as long as you have an idea how they look like. And obviously, this is a right triangle, and Pythagorean theorem a squared plus b squared equals c squared applies. A and b are the sides, and c is the longest side opposite the 90-degree angle. Therefore, we can find c as follows. So c squared is, therefore, a squared and b squared add up this side squared and this side squared, giving us 68. This is the precise answer, and that gives us the value of c. Now, the next one, we want to find capital B. Tan of B is b over a, 2 over 8, or 1/4. So B is tan inverse of 1/4, which gives us 0.25 radians or 14.03 degrees. The reason we want to put it in degrees because this was given degrees. And the last angle would be 90 and 14.03 added up, subtracted from a total of 180, or simply put, A and B are supposed to add up to 90, so 90 minus that. So there are two ways to do that. Because it's a right triangle, these two must add up to 90. Or in general, A plus B plus C, they add up to 180. Find the missing, and we're going to put the C here. So by solving a triangle, we mean find all the sides, all the angles. Could you please read this?
A girl is standing 20 feet in front of a Christmas tree. The star at the top of the tree to the bottom of her shoes makes a 60-degree angle. How tall is the Christmas tree? What is the distance between the girl and the star? Draw a diagram.
Perfect. Anytime you do word problems involving trigonometry, when the diagram is missing, you got to come up with that to make sure you understand and your readers exactly what you're thinking. So here's what's happening. So here's the star. Okay. Here's the 60-degree angle. Here's the 20 feet distance. So 20 feet away at an angle of 60 degrees, we are interested in finding this distance or height. We're going to call it X. So one easy way, this is a right triangle. So tan of 60 is the opposite, which is X, over the adjacent, which is 20. So X is the product of those two. And using a calculator, a bunch of decimals, you come up with the answer. Because this is 20 feet, then X is in feet also. So that's the first part. The second part, what is the distance between the girl and the star? We want this distance, which we call it C now, using Pythagorean Theorem, a squared plus b squared equals c squared. So we square this one, we square this side, which we found it, and that becomes c squared. Now the number is almost 1600, and when you square them up and add them up, and c becomes 40 feet. We are given the following, where one side is 8, another side is 5, and this is 67 degrees. And in a sense, we're going to solve the triangle by finding all missing pieces. So again, bear in mind, if we were to put, this is capital A, so this is lowercase a. This is capital C, this is lowercase c, and this is lowercase p, as an example. So side, notice side angle, SSA, it's called side angle is given. We are going to use the sine law, and I remind you, the sine law says sine A, capital A over lowercase a, sine B over B, sine C over C, they are equal. And with that being the case, if we put sine of 67, so we are looking at this one. By the way, sometimes you can use the reciprocal, but it comes from the proof of the sine law that you can use this reciprocal. So a sine of 67 over 8 is the same as sine of A over 5, because everything is given except sine A. The cross product will give us the answer. So 8 times sine A, 5 times sine 67, divide by 8, that gives you sine A. And This becomes a value. You can use a calculator, and A really gives you two answers. I want you to know that. However, clearly we are dealing with an angle that is in the first quadrant between 0 and 90, and the answer is unique at 35.1 degrees. So this all goes to a calculator and can be easily found. Therefore, we can find the last angle. Everything is given. We know the total interior angle must be 180. So if we add A and C, which gives us 102.1, subtracted from 180, gives us the last angle. We also want to find the missing side AC now, which we will continue with this. And we say sine of 67 over 8. By the way, we rather use the ones that is already given instead of the one we just calculated to be on the safe side. I want you to know that. Sine of 77.9 over AC. Again, the cross product will help us find AC. When you multiply these two and divide by this one, you get AC using a calculator, bunch of decimals. It results in AC being 8.5. I don't see any units given. We just give it without units back. And to be on the safe side, we write all of them again. So we have AC at 8.5, angle of A 35.1 degrees, angle of B 77.9 degrees. So all the missing values are found. Now, when we use side angle and we use sine law, we could get to a case known as the ambiguous case. So in general, H is equal to B times sine A. I hope you realize why. Okay, because simply put, sine A is the opposite, which is H, over the hypotenuse, which is B, and the cross product gives you that. So if A happen to be smaller than H, which has a value of B sine A, when that happens, there is no way to come up with any triangle. If H or B sine A is less than A and less than B at the same time, that means less than A such that A is less than B in this format, then we can have two triangles. And so that's why it's called the ambiguous case, and you have to work it out to figure it out. It's really not that big of a deal. Let's look at this case where A and B, two sides are given, and capital A represents the angle A. Therefore, it's a good practice to put them in there. There again, doesn't have to be to scale, because we may not know exactly what we end up with, but a rough sketch is good enough. So capital A is 50 degrees. So this is lowercase a, which is 3, opposite that. Lowercase b equals 2, so the opposite is angle B. And if this is C, this is lowercase c. We can put it there if you like. So this is lowercase c, which is again missing. So we are going to solve that by using the sine law, and we can write all of them in one shot. Let's write the whole thing. Look at this one and plug in whatever you have. So sine A over lowercase a, so 50 degrees over 3. Sine B over lowercase b, which is 2, and sine C over lowercase c, 2. Both of them are missing. So let's look at this 2 and find sine B. So if you look at this 2 and you do the cross product, sine B becomes 2 times sine 50 over 3. And again, you use a calculator, you come up with the answer. And the answer is 0.511. I want you to concentrate on that. Sine B has this value, let's say almost 0.5, right? So you come up with two answers. 30, I hope you realize that 0.5 is 30 degrees, so 0.511 is a little bit larger than that. So 30.7 degrees. And the second case, really, it happens in the second quadrant. 180 minus this number is the second case. So there are two possibilities for B, which means there may be two triangles. Let's find out what happens. So with case one, we will continue. This works for both cases, remember that. With case one, we use B equals 30.7. So if B is 30.7 and A is 50 and the total interior angle is 180, we can find the last angle. C is 99.3. I want to make sure everybody understands why. So let me just quickly put this in. With case one, this is 30.7 degrees. A plus B plus C is 180. And so add these two, subtract it from C, you get 99.3. So if C is 99.3, you can go to this one and say, well, I have sine of 99.3. And the first one and the last one, put them together. Again, do the cross product, you find the lowercase c, which means 3 times sine of 99.3 degrees over sine of 50 degrees, and c becomes 3.86. I hope everybody can go from here to here. It's a basic elementary algebra. Cross product will find the missing c. And so we are going to write down for case one everything that we have. All angles, all sides. Let's discuss case two, and case two is not possible. How do we know that? It's very simple. The very first thing you find is the missing angle. A is 50, B is 149.3. You add them up and you subtract it from 180. These two, the sum is more than 180 degrees. Second case doesn't exist. So I hope you realize how you tackle that. The very first thing you do, you look for the angle. Let's say this was such that the sum was less than 180. Let's make it up. Let's say it was 130. Okay. 120, let's say. 120 and 50 is 170. Then the last angle would be 10 degrees and you continue. So it is possible that we have case two. In this case, the very first thing that shows you it will fail is that the sum of angles is already over 180. It has to be less. Even equal to 180 does not cut it. Now we have the following ABC, and we want to find and solve the triangle. So we have SSS, side, side, side. We use cosine law, which says a squared equals b squared plus c squared minus 2bc cosine a. Now, I hope you realize if you want to solve for cosine a, you can put b squared and c squared on the other side, okay, and then divide by negative 2bc. That's how we get cosine a. So in this equation, you can solve for cosine a. Also, I want to share one more thing. I hope you realize that Pythagorean theorem is a special case of the cosine law. If A is 90 degrees, cosine of 90 degrees is 0, and you get to Pythagorean theorem. A squared equals b squared plus c squared. Let's plug into a calculator the given info. So we have all sides. We need to find the angles. That's why we use the cosine law. And the reason I'm giving you this formula because, well, we really have to use this formula. Cosine A is b squared plus c squared minus a squared over 2bc. Notice you want cosine of a, so you have minus a squared. So plug it into that. And cosine A becomes negative 19 over 36. That means A is cosine inverse of that number. And cosine is negative in the second quadrant, 121.86 degrees. So A is 121.86 degrees. It is larger than 90 degrees. And so with that being the case, we do the same thing for cosine B. So I hope you realize if you replace the A with B here, that means you got to replace this A with B. Okay. And so everything else is the other variables, namely A and C. For example, this becomes A and C. C is here, so this becomes A. So again, I hope you can make the transition from this formula to this formula. A is changing to capital B. You do the math, and cosine inverse of this 91 over 96 gives us 18.57 degrees. So we have 121.86 degrees. (18.57 degrees). Clearly, this angle would be 180 minus the sum of these two, because the total interior angles must add up to 180, and that results in 39.57 degrees. Again, how do we come up with that? Add these two, subtract from 180. Add these two, subtract from 180. Very straightforward. All right, we have this situation which is known as SAA, side. We have side C, and we have two angles. So the very first step is to find the third angle, because they add up and you have to subtract them from 180, then use the sine law. So this would be the general format. Let's again come up with the drawing and say this is 45, this is 95, this is 5. Okay, so what is this? Add these two up, subtract it from 180, that gives us A, which is 40 degrees. And now we have all the angles. We have one side, use the sine law. So sine of 95 over 5, because the side is given opposite the angle C. Now sine of 40 over A, cross product. A is the product of these two divided by sine of 95. Using a calculator, give us the value of A. Now we use the sine law again. This part doesn't change, but over here we change it to 45 over B because we want to find the missing B. Again, what is B? The product of these two numbers divided by sine of 95. And calculator will help us get to the answer. So we have A, B, C. We have two angles. We got the third angle. Let's just write everything we have. So what you can do, of course, you can write them right here if you like. 40 degrees, this is lowercase p. And lowercase a. And there you have it. So basically, the missing ones. All right, again, capital A and C are given. So we are looking at two angles with one side. That means SAA, side, angle. So quickly we have two angles, add them up, we get the third angle, and then we use a sine law. So we repeat the process and we write the given here. We add those numbers that are given. So this side is 4, so on and so forth. So let's just actually write the following. So this is lowercase a, this is lowercase c, this is lowercase b. And so we add up 55 and 20 and subtract it from 180. We end up with 105. That's the first thing we do. You can subtract both, or you can add them up and subtract them. Either way is fine. So we have now all the angles. We have one side, namely a equals 4. So plug it into a sine law. So sine of 55 over 4 equals sine of, let's say, 105 over b, cross product. So 4 times sine 105 over sine 55. That gives us 4.717. Again, the number of decimals. Normally you have to go one more, but I just wanted to show you more decimals and you follow what they are asking you to do to get 4 credit. I showed the cross product also. The last one, okay, sine of 105 over 4.717, sine 20 over c. Either one is fine. I did this on purpose. Again, you do the cross product and you find the c. But what I want you to know is that you really, instead of that, I rather use this one. Again, I did this on purpose. I don't recommend you do that. Here's the reason. These two are given, no doubts about them. This maybe somehow we made a mistake here. You see this calculation, we did the calculation here. Maybe we made a mistake. Don't take a chance. I did this to explain it to you. It works out if we don't make a mistake, okay? But don't take a chance. Stick with what is given to you. That is a better strategy, okay, everybody? I did that on purpose. So let's write everything that we have. A and C were given. We are adding B to be 105 and the sides A, B, C. And again, it's an approximation because we did just with some decimals. We want to use the law of cosines to prove the left side, cosine A over A, cosine B over B, cosine C over C is equal to the right side, A squared plus B squared plus C squared over 2ABC. And you can start from one side, normally the more complicated one. And I would say this one because we can take a common denominator of ABC. So on the left side here, if I take a common denominator of ABC, I have to multiply this one by BC, this one by A and C, and this one by AB. This is what we have. Now, notice if you go back to this line, if you ignore the 2, -2, you have BC cosine A. Do you see BC cosine A? So if I were to sign this, I would take B squared to the other side, A squared minus B squared minus C squared divided by -2. So that's the first one, and you can see the rest. So let me see if you can make this transition from here to here. So what do? Subtract B squared, subtract C squared. That's what we have. Divide by -2. Now, dividing by 2, putting the negative sign at top, or dividing by -2 makes no difference. So please, make sure you see how we arrive at this. Now transition from here to AC cosine B and AB cosine C is this fairly simple. Just remember what you do. You replace the A with B and the same thing here. So as long as you can make this one simple manipulation of moving the B squared and C squared dividing by -2, you can figure out the rest. So let's replace each and every one of them by those, which means this one goes at top, this one goes at top, this one goes at top. And they have a common denominator of 2. We can put the 2 down. I hope you realize you can put all of them at top over 2. So I'm going to put the 2 down here. Now, it is up to you to figure out how you can simplify this. Just do the first step for you. So this is, we're going to apply the negative minus a squared plus b squared plus c squared. I want to use a different color. Minus b squared plus a squared plus c squared. Again, I want to change color. Minus c squared plus a squared plus b squared, and that gives us the right hand side. And I hope everybody is okay with that. So for example, minus a squared and a squared, b squared and minus b squared, c squared and minus c squared, and you're left with the rest of them, which is c squared in order. I put them in order on purpose. So what is left? C squared plus a squared plus b squared, and I hope you realize that it's the same as that one. You'll probably have to rewrite it as that. It's not a big deal, but very straightforward. That's the proof. Could you please read this?
An aircraft is spotted by 2 observers who are 1,000 feet apart. As the airplane passes over the line joining team, each observer takes a sighting of angle of elevation to the plane as indicated in the figure. How high is the plane?
Excellent. So let's say this side is y and this height we are looking for is h. This angle P R Q, this angle is 105 degrees. Why is that? Well, look at the left side is a right triangle. Look at the right side is a right triangle. So this one is 40. This one must be what? 90 minus 40, which is 50. This is 35. This one must be what? 90 minus 35. So this becomes 50. This becomes 45, 55. And they add up to 105 degrees. So I hope everybody is clear on that. All right. Now, sine of 105. So we are looking at the sine law. This angle, sine of 105 over the whole thing, 1000 here, is sine of 35 over y. We are looking at the sine law. And so cross product will do the job. Y is equal to 1000 times sine 35 over sine 105. Using a calculator, we get the value of y, or simply PR, with a bunch of decimals. Now, if you look at this left triangle, which is a right triangle. Sine of 40 is the opposite, which is h, over the hypotenuse, which is y, and h is missing, which is the product of sine 40 and y, which we found it to be 593.81. And using a calculator, we come up with the answer with a bunch of decimals, 381.69 feet. That would be the answer. Okay. Could you please read this?
Two homes are located on the opposite side of a small hill. To measure the distance between them, a surveyor walks a distance of 50 feet from house P to point R. Use a transit to measure angle PRQ, which is found to be 80 degrees, and then walks to the house Q, a distance of 60 feet. How far apart are the houses? Draw a diagram.
Perfect. But when a situation like this comes up, we should be able to come up with the diagram. So take a look at the diagram. So this is the two houses, and X represents PQ, or the distance between the two. We are going to go down somewhere and go back up. And how much do we go away? We go this way 50 feet, coming back to the 60 feet, making an angle of 80 degrees. So you start from, this is how you actually measure the distance. You come on down. If it's impossible to measure the distance between the two directly, of course, if you can calculate it directly, that would be wiser. But for some reason it can't, you can come on down with some sort of an angle, and then back to the second place. The angle, you can measure it at 80 degrees in this case. This distance can be calculated and measured, 50, and this is 60. So now we are dealing with Sas, side, angle, side, or Sas cosine law. So X or PQ is of interest to us. So PQ squared or X squared is the two sides squared, 50 squared plus 60 squared, then minus 2 times this product of the two, 50 and 60 in any order, and cosine of in between. And I hope you realize at this point, you just plug it into a calculator and the calculator will answer you. Again, with a bunch of decimals. You want to follow how many. So PQ squared is given, take a root, 71.12 feet. Always answer with proper units if units are given. Could you please read this?
Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet and the second has traveled 350 feet. How far are those boats apart? Draw a diagram.
Again, the key is drawing a diagram to understand what happens. So take a look. So they start from some point A, and they make a 135-degree angle. One is going about 300 feet, whereas the other one 350 feet, and we want to know the distance between the 2 points. So look at the given here and the diagram. They must agree. So first understanding the question, then more importantly, coming up with the proper diagram, or it doesn't work, we need to use the cosine law. Again, it's Sas, side, angle, side, and cosine law is in order. So this is the general form. So A, actually BC is A. Okay, BC squared or A squared is equal to the side squared, this one squared, minus 2 times the first times the last, and the cosine in between. So a squared is 300 squared plus 350 squared minus 2 times 300 times 350 cosine of the included angle. They call that the included angle. Let me just write that actually. And just plug in, by the way, cosine of 135 degrees is the same as cosine of 45 degrees. In the second quadrant is negative, so you know precisely is minus square root of 2 over 2 in case. In other words, without a calculator, you should know that. You calculate a squared with a bunch of decimals, you take a root, and it's about 600 or 600.83, okay, almost 600, 601, if you will, feet. That's how we come up with the answer. Sas will do the job. So I hope you see how important it is to have the proper diagram. Could you read this, please?
Two cars leave an intersection together, traveling on courses with an angle of 45 degrees between them. If each travel 500 feet, how far apart are they? Draw a diagram.
Again, it's all about understanding what's given and coming up with the proper diagram. Okay. So one is going this way, one is going this way, making an angle of 45 degrees. Each one is going 500 feet, and we are interested in the distance between the two. Again, cosine law. Cosine law. How about writing it differently on purpose? C squared is a squared plus b squared minus 2ab cosine theta. So I want you to be exposed to various ways of writing that. Okay, this is another way of writing. And so plug in. A and B are 500, and the included angle is 45 degrees. I'm going to assume everybody can do the math. Plug it into a calculator, and the side C will be found, which is the distance between the two, 382.68 feet. Could you please read this?
Two cars leave an intersection together, traveling on courses with an angle of 30 degrees between them. If one travels 1,000 feet and the other travels 720 feet, how far apart are they? Draw a diagram.
So we are repeating the same question in essence. The angle in between is 30 degrees, and one goes 1,000, the other one goes 720 feet. So just the numbers are different. The concept is absolutely identical. So the angle is 30 degrees, and they go different distances, 720 and 1,000, and we want to know what is the distance between the two. Again, we are going to use cosine law. So 720 squared plus 1,000 squared minus 720 times 1,000 cosine of 30 degrees. By the way, cosine of 30 degrees is square root of 3 over 2. And you use a calculator again. You come up with the distance of 520.89, almost 521 feet. So again, it depends on how many decimals you need. But I hope everybody is clear that the two questions are practically the same. We are just changing numbers. And the importance of the diagram that will help us see how we do the problem. And that's why I wanted you to see both of them on the same page, because practically they are the same question. Could you read this, please?
George is standing 35 feet in front of a house and notices that the angle of elevation from eye level to the top of the house is 60 degrees. Find the height of the house. Draw a diagram.
Well, first and foremost, what are we dealing with here? So this is the angle of elevation, because when you have a horizontal line and the object is above that, the angle it makes with the horizontal line, and this is the line of sight, that is the angle of elevation. On the other hand, if the object is below the horizontal line, this is called the angle of depression. So first, reminding you of what each one is. So that's important to understand. And now let's do the drawing. So we're standing here. Here's the horizontal line, looking up, having the angle of 60 degrees, the distance of 35 feet here, and the height is of interest to us. So the eye level, 60 degrees, 35 feet in front of the house. We are going to calculate. Now this becomes very easy as long as we understand this concept and we have this drawing. So we can use the tangent, which is the opposite over the adjacent. Therefore, tan of 60 degrees is the height, the missing height h over 35. So h is the product of the two. And using a calculator, 35 tan of 60 degrees gives us 60.62 feet. By the way, tan of 60 is square root of 3 as far as it being a common arc or angle. I'm sure everybody knows that. So this was dealing with the angle of elevation. Everything depends on the proper diagram. Could you please read this?
George is standing 27 feet in front of a house and notices that the angle of depression from eye level to the top of the house is 73 degrees. Find the height of the house.
Again, angle of elevation versus the angle of depression is discussed. Okay, in front of a house and the angle of elevation from the eye level. Okay, here's the eye level. Okay, that is 73 degrees. So bottom of the house. And so this is 27 feet. This is 70 degrees and h or height is missing. Again, the tangent will do the job. Tan of 73 degrees is h over 27. Therefore, h is the product of the two. Using a calculator, we end up with 88.31 feet. 88.31 feet. Again, the whole thing is in the diagram and being able to properly draw that. Could you please read that?
A balloon is flying at a height of 600 feet, directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram.
Perfect. Again, it's all about the diagram. If we could do that properly, we can easily come up with the answer. So let's see what we need to do. So here's the balloon at a height of 600 feet, directly above the Statue of Liberty. There's an airport 5 miles from the Statue of Liberty. And we want this angle known as the angle of depression. So take a look at what angle we need. Now, this is the same, this angle is the same as this angle. And therefore, we calculate this one easily using tangent, because tangent of this angle is the opposite, which is 600 feet, over the adjacent, which is 5 miles. Now, it is extremely important to know we have to use the same units. 1 mile is 5,280 feet. So we do the conversion first. 1 mile corresponds to 5,280 feet. Remember, you're going to cancel out the feet. This is called unit conversion. You can put this one at top, 1 mile at the bottom, or vice versa. You have to make a proper decision because you want the feet to go away. Then this is at the bottom. In essence, 600 divided by 5280 gives us this much, 0.11363. I wanted to use many decimals in miles, and now we're going to replace the numerator. So theta is tan inverse of this number. And that, using a calculator, gives us 1.302 degrees. Needless to say, this is not to scale by any means. So it's a very small angle of 1.302 because this distance is much smaller than this distance. This is the reason, everybody. Could you please read this?
A rocket takes off at a bearing of
North 30 degrees east.
Okay. North 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram.
So first, let's see what we remember about bearings. Bearings start with either north or south. Either north or south comes first. And there's some sort of an angle that makes with the north or south. And we show the direction by saying it's east or west. For example, if you look at this point, if we're going this way, so if we first mention north and then we mention east, in between goes the angle that it makes with the north-south, which is 30 degrees. If we are going to look at this one, this angle is 70. So we first write north, then we have to write the side W, but what goes in between? The angle that it makes between the two, which is 70 degrees. Whereas this one, we have to mention south first, because the angles we mention, it must be always, between 0 and 90 degrees. So first we mention south, then we mention west. What's in between? 50 degrees. Now, as an example, this one, I didn't put the answer yet. This one, looking down, first we put south, then we put east. What do we put in between? 20 degrees. So this would be south, 20 degrees east. So that was a little lesson to remind everybody about this. And now let's come up with the diagram. First and foremost, in this case, north 30 degrees east means in this direction. Here's north. Here's east, and here's the direction, and it makes a 30 degrees in between. Of course, this is not to scale, but that is a rough sketch. Okay, I just wanted to make sure we understand. We're really looking at this guy, okay, in essence. Now let's read after, so that's the direction, okay, that's the direction. After flying for 900 meters, so we're going this way. How much? 900 meters. Then the pilot turns 90 degrees. So 90 degrees, here's the 90 degrees, everybody. 90 degrees, we make a 90-degree angle. But which way? Up there or down there? Northwest, so up there. So this is a 90-degree angle. After flying for 1,000 meters, so this distance now is 1,000 meters. What is the new bearing? Well, after that, we are here. So we want the bearing for this direction. Now, what do we need to write? We are going north and we are going west. So northwest is the answer. So northwest, we just need to find the angle. Again, we're going to write NW. We're going to find a number to put in between. So first understand this means northwest. And now the missing is this angle. So that's understanding the concept. So this whole thing, theta, we call it. And it can be found, tan of theta is the opposite, which is 1,000, over the adjacent, which is 900. So theta is tan inverse of that. Using a calculator gives us 48.01. 48.01. Now, this whole angle is found to be 48.01. This angle, that means from here to here, we know it to be 30 degrees. So subtract from that. So this is the one we want. We have this angle. And we know this one to be 30 degrees. Subtract 30 from it. And we already know it's northwest. Put this angle between N and W, and there you have it. This is your final answer. That's how we find it. I hope everybody's comfortable with that. Could you please read this one?
An aircraft leaves an airport from a runway with a bearing of north 40 degrees east. After flying for half a mile, the pilot turns 90 degrees and heads towards the southeast. After flying for 1 mile in this direction, what bearing should the control tower use to locate the aircraft? Draw a diagram.
So we are looking at north 40-degree east. So first and foremost, what does it look like? Again, this is not necessarily to scale, but this is north 40 degrees east. So there you have it. So somewhere in this direction, again, doesn't have to be to scale, but you get the picture. So after flying for half a mile, so we are going in this direction and we go half a mile. The pilot turns 90 degrees. So 90 degrees means like this, make a 90-degree angle. Which way, we're going to read it in a moment, but this means 90 degrees. Going south, east, so going this way. So again, this is 90 degrees, can go either way because it says southeast, going this way, this angle is 90 degrees. After flying for 1 mile, we want to know what's the bearing. All right, so let's figure out what the bearing is by first understanding which way we are going. We are going this way, which means we are going southeast. So the answer is southeast. We need to find this angle, everybody. Okay, we need to find this angle. So again, we already know we are going southeast. So SE, in essence, you can write even, this may not be a bad idea to write. So we know it's south, we know it's east. We just need to figure out this angle. Okay. So that's the idea. All right, so again, we notice that this angle is theta, and the tangent can be found as the opposite, which is 1 mile, over the adjacent, which is 1/2. 1/1/2 is 2. This is 2. So theta is tan inverse of 2. Using a calculator, we get 63.43 degrees. So this angle is 63.43 degrees. What about this angle? We know it's 40 degrees. So we have this one as 40. We have this one as 63.43. And we know this whole angle is a straight angle of 180. So if I add this number to 40 and subtract it from 180, I get this angle. So we have this angle, everybody, which is 40 degrees. So let's add them up. So we are looking for alpha. All of them, they add up to 180. 40 plus theta plus alpha is 180. They all add up to 180. So therefore, alpha is 180 minus the sum of the other two, giving us 76.57. We've already figured out it's southeast. Put the number in between. South, 76.57 degrees. East is the final answer.